Okay, so if you recall, the purpose of the urea cycle was to safely rid the body of excess ammonium ion because it is toxic, right? So, and of course, the urea cycle requires properly functioning urea cycle enzymes because those enzymes are what actually allow the processing of that excess ammonium ion. So, what if someone has a deficiency in one or more of those enzymes? Well, that's a problem because that means that that person cannot properly get rid of ammonium ion. And that would mean that there would be an increase in the concentration of NH4 plus in the blood, which is called hyperammonemia, which is really, really bad and dangerous, and it's potentially lethal. Okay. So, is it possible to determine which specific enzyme or enzymes are deficient? If so, how? Well, the answer to the first part is yes. And if so, how? Well, the intermediate prior to that enzyme, that deficient enzyme, will build up. So, what does that mean? Let's use an example here. Arginosuccinate is an intermediate of the urea cycle right here. So, let's say that there's a buildup of arginosuccinate. So, we have an increased concentration of arginosuccinate, an abnormal increase in concentration. That means that there is a deficiency or a low amount of arginosuccinase. That's this enzyme, right? Because this is the enzyme that's supposed to process arginosuccinate. Well, so what's the deal here? Basically, arginosuccinate building up means that it's not going through in the urea cycle pathway. It's not going through to produce arginine and fumarate. Why isn't it going through? Well, because there's a deficiency in the enzyme that acts on it. This enzyme is what's supposed to allow arginosuccinate to be converted into arginine and fumarate. But if that enzyme is deficient, or that means that there's not enough of it around to process the arginosuccinate that's there. Okay, so the intermediate prior to this enzyme, so this is the enzyme that we're talking about, the intermediate prior to it, right before it, is arginosuccinate. That's how you can identify a deficiency in one of those enzymes, and that could apply for these other enzymes here. So, can patients with these types of disorders be treated with diets free of protein or free of a nitrogen source? The answer is no, because there are these things called essential amino acids that are necessary to consume for survival. The essential amino acids are basically amino acids that your body cannot synthesize. The non-essential amino acids are amino acids that your body can synthesize. So essential amino acids are amino acids that you must consume in your diet because you do need all 20 amino acids in order to survive. But the essential ones, you can't actually make them yourself, so you have to eat them. So having a diet free of protein or free of nitrogen would be free of essential amino acids, which would be bad. That means survival is not possible. By the way, nothing I say in this video should be taken to be medical advice. It's all approached strictly from an academic perspective. So if you have any questions about any of this, that it's not from an academic perspective, if you're looking for medical advice, please go see your doctor. Okay, so some people might say this and think, okay, which amino acids are the essential ones? Well, back in the day, one of my biochemistry classes, I had a TA who came up with this. Milk for watching TV, which is kind of weird, but each underlined letter is the one letter code for the amino acid that's essential. So the essential amino acids are MILK, which is methionine, or which are methionine, isoleucine, leucine, lysine, and then F, phenylalanine. The W in watching is tryptophan. H in watching is histidine, and T and V are threonine and valine. So it's kind of weird. Milk for watching TV. I don't drink milk when I watch TV, but the point is I use this to remember, and I haven't forgotten. So it might be good for you to remember this. Anyway, so if we can't treat these patients with diets free of protein, what then are the treatments for patients with these types of disorders? Let's see here. Basically, when it comes to these treatments, they focus on basically getting rid of excess nitrogen. which is basically doing the job of the urea cycle without the actual urea cycle. So one treatment option is low protein diets. And the idea behind that is simply that there's less nitrogen intake, right? Which means that there's less of a need for the urea cycle, which means it's less likely that ammonium ion concentrations will get too high. Because just because one of the enzymes in the urea cycle is deficient doesn't mean that the urea cycle cannot happen, it just can't happen to a great extent. So you can still get some protein, just not too much, making it so the workload for the urea cycle is not too high. So less nitrogen in, less of a need for the urea cycle, and the deficiency is seemingly less detrimental. Okay, there's also the option of administering benzoate or phenylbutyrate. And what these guys do is they basically pick up amino acids, and of course amino acids have nitrogen on them, and they take them to the urine to be excreted, which forces a cell to remake them using the excess ammonium ion in the blood and cells. So what does that mean? Well, let's take what I've drawn here and figure it out. Benzoate specifically excretes glycine, and so cells respond by making more glycine using ammonium ion that's freely floating. So what's going on with benzoate? Well, this is benzoate here. It's going to get converted to benzoyl-CoA by adding coenzyme A and some ATP. And the benzoyl-CoA's CoA here is going to be replaced by glycine, and we get benzoyl glycine or hippurate. And what's important about this molecule is that it can be safely excreted in the urine. What else have we said can be safely excreted in the urine? Well, urea, right? We have those nitrogens attached to it, and that's the safe way that we can get rid of nitrogen. Benzoyl glycine, this nitrogen right here, is being safely excreted. So basically what's happening is that this molecule is doing the job that urea pretty much does, okay, by getting rid of that nitrogen. So except it's not just the nitrogen, it's a whole amino acid with glycine. So if glycine is basically being taken away from this cell and the cell has to respond, it's kind of like, hey, you're taking my glycine. Well, I can't do anything about it. I guess I have to make more glycine using the excess ammonia that's around, which will end up decreasing the concentration of ammonium ion that's around. Phenylbutyrate does pretty much the same thing except with a different amino acid. It does it with glutamine, so it excretes glutamine, and the cells respond by making more glutamine, again using the NH4+ that's around. So this is phenylbutyrate here. We'll add a coenzyme A and an acetyl-CoA comes off, turning that phenylbutyrate into phenylacetate right here. And we'll add a coenzyme A and some ATP. These details aren't that important to me. I don't know if they're important to you, so don't take that the wrong way. Anyway, this phenylacetyl-CoA, the CoA group right here, is replaced with glutamine, and that glutamine is now attached here. And we have phenylacetylglutamine, which, like hippurate or benzoyl glycine, can be safely excreted in the urine, and it's going to take these two nitrogens with it. So the cell has to respond upon losing this glutamine. It has to respond by making more glutamine to account for that loss, and it's going to use the excess ammonium ion in order to do that. So the overall effect of administering these drugs is to decrease the nitrogen levels, which, like I said, is basically doing the job of the urea cycle without the actual urea cycle. Anyway, I hope that video was helpful. Thank you for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you, and happy studying.